Hi students, today we are going to discuss block on block concept. It is very important and a little tricky problem. And if you understand this, it is very easy to solve. If you don't understand, it will be confused where we should apply what formula, where we should apply force. Okay. Now this is a basic and simple example. On the floor B and A, mu is equal to 0. There is a friction here. Okay. Now there are series of questions that can be asked. First, find, here 15 Newton is given. I am changing the question. Find maximum force that can be applied on upper block so that all the blocks move together. Maximum force that can be applied on the upper block so that all the blocks move together. Let's draw a free body diagram of this. A, upper block, and there is a friction here. There are two types of friction, static friction and kinetic friction. Maximum force we are considering, so there should be no relative motion. Whenever we are finding maximum force, whenever there is a block on block system, I will tell you, first of all I will tell you the steps to solve. Steps to solve. First, determine maximum acceleration of the block on which force is not applied. Determine the maximum acceleration of the block on which force is not applied. Next, assume all the blocks are moving with, I am saying this is A max with A max. Third step, determine F max by using A max. Okay, this is the easy one. Up to 3 steps which I gave you, it's common for any case. After that, there are some other cases also. We have to increase the number of steps also. As of now, to determine F max, these 3 steps are sufficient. Now I am drawing the diagram. On this there is a 50 Newton force and the 50 Newton force on block A and B. A, B, they are placed on a friction mu. Here is a friction, there is no friction. Okay. What is our first step? Determine maximum acceleration of the block on which force is not applied. Now in the block on block case, either the force is applied on a upper block or either lower block. Sometimes it is applied on both the blocks, but as of now we have one block. Now on which block the force is not applied, A or B? B. Now I am drawing the B free body diagram. Now how much is the maximum friction here? Maximum acceleration applied, and there is one more step. Determine maximum frictions at all contact surface, all contact surfaces. Before the first step, this is the 0th step you assume. Determine 0th step, you can assume. Determine the maximum friction at all contact surfaces. What is the I am considering this is F1, this is F2. What is the maximum friction? Mass is MA, MB. F1 is equal to, draw free body diagram, MA and the normal, the downward direction MA into G. F1 is equal to mu into MA into G. What about F2? Because there is no friction, F2 becomes 0. This is the friction, maximum frictions. F1 to max, F1 max. Now this is 0th step is over. What is the first step? Determine the maximum acceleration of the block on which force is not applied. This is a block MB, the force is not applied on it. 0th step to over. Now the first step. How to get the maximum acceleration of this block? How much friction that acts on the body? See, MA tries to go forward. If I draw free body diagram of MA, this is 50 Newton. The body tries to, tendency is to go right side, right? And friction in which direction it acts? Friction. Okay, F1. The same friction will act on a B in which direction? In the right direction. The friction which is opposing block A is the cause for movement in block B. This is F1. Okay. Now what is the maximum value? We should get a maximum acceleration. Should we apply F1 max? A max is, we should get A max. Now are there any friction in the backward direction? No, it is equal to 0. F1 max is equal to MB into A max. F1 max is equal to how much? Mu into MA G. MB into A max. A max is equal to mu MA over MB multiplied with G. This is the maximum acceleration. We got, say, first step is also over. Maximum acceleration we found. And what is the next step? Assume that all the blocks are moving with the same acceleration. Why we are assuming that third step? Can the lower block move with more than A max? No, it's impossible. The maximum acceleration of this is mu MA over MB by MB into G. Now if we draw, so that upper block can move with whatever acceleration it want because applied force, and total mass is equal to how much? MA plus MB, and first whatever value is given here is 50 Newton na, forget about 50 Newton. We should forget. Now if you see any question, if they give any data here, 50 Newton, 100 Newton, 120 Newton, 30 Newton, whatever Newton they give, you forget about this part. First we should know the tendency of the blocks, how the blocks are moving. Blocks are moving together or blocks are moving separately, that we should know. To know that, first we should find, how we will find? We find using finding maximum force. Now F max is equal to, and this is A max. F max is equal to MA plus MB multiplied with, what is the A max? Mu MA over MB into G. This is a maximum force that can be applied on the upper block.